Hello students, welcome to my channel GVS Chem. In this video, I am going to explain chemistry of carbon compounds for class 10 students. The unique nature of carbon. This is a part of revision series for board examination for the students of different syllabi, that is state syllabus, CBSE, ICSE and others. Please subscribe to my channel. Like, share and comment my videos.
Hello students, in this video I am going to explain chemistry of carbon compounds, the versatile nature of carbon. Chemistry of carbon compounds means carbon along with a few elements, that is hydrogen. Major number of compounds are formed with carbon and hydrogen. And very few elements like nitrogen, oxygen, sulfur, phosphorus also combine with oxygen, carbon to form compounds. So the number of compounds formed by carbon is much more greater than the number of compounds formed by all the other elements put together. That's why we have to study the carbon compounds as a separate chapter. Now, carbon, atomic number 6 and mass number 12. So with atomic number 6, it has a configuration 2-4. 2 electrons in K shell, 4 electrons in L shell. Therefore, valence shell has 4 electrons. 4 electrons. Now, as per electronic theory of valency, our valence shell or outermost shell can accommodate 8 electrons. So, if valence shell or outermost shell has 8 electrons, then its octet is completed. So, if valence shell has 8 electrons, it is said that its octet is completed. Octet is completed means its stability is more. It does not react with other elements. Therefore, elements having octet configuration have maximum stability. So elements with octet configuration have maximum stability. Therefore, they do not react with other elements. But carbon has only 4 electrons. So what happens? Carbon has 4 valence electrons. What happens? It has to gain. There are 2 possibilities for it. It has to gain 4 electrons to get octet. But can it gain 4 electrons? Gaining 4 electrons is highly difficult. So 4 electrons it does not gain. And what is the other possibility? If it loses 4 electrons, then it has a duplet configuration. So atoms having duplet configuration also has a maximum stability. So to get a duplet configuration, it has to lose 4 electrons. So losing 4 electrons also is very difficult. So carbon can gain 4 electrons. Carbon can neither gain 4 electrons nor lose 4 electrons. So what is the other possibility? So carbon has to form 4 covalent bonds. Carbon can form 4 covalent bonds. So if it forms 4 covalent bonds, then carbon gets its octet configuration, hence it gets a stability. So this electronic configuration we can also write 1s2, 2s2, 2p2. So in NLX method also we can write the electronic configuration. 2s and 2p is valence shell, therefore valence shell has 4 electrons. Before discussing the covalent compounds formed by carbon, let us learn the simple covalent bonds. So some simple compounds, simple molecules with covalent, some simple compounds with covalent bonds. Example hydrogen, H2 molecule. In hydrogen atomic number is 1, therefore its electronic configuration 1 in the K shell, or 1s1. It has only 1 electron. So hydrogen has to get duplet configuration, duplet to complete, to get the stability, and of course after gaining 1 electron it gains helium configuration, therefore it gets the stability. So hydrogen here plus another hydrogen here. Two such hydrogen atoms contribute their unpaired electrons and form a pair of electrons in this manner. So H double dot H. Since only one pair of electrons is shared in between both the hydrogen atoms, it is called single covalent bond. Or this hydrogen molecule is also represented in this manner, 2 circles, H here. So this is a hydrogen molecule with one pair of electrons shared in between both the hydrogen atoms. Now let us see the oxygen molecule, O2, oxygen molecule. What is the atomic number of oxygen? Oxygen has electronic configuration 8 and its configuration is 2, 6, or 1s2, 2s2, 2p4. So it is deficient of 2 electrons to complete its, it needs 2 more electrons to complete its octet. So if it completes its octet, it gets the nearest earth gas configuration, that is neon. It gets the nearest earth gas configuration, that is neon. So 2 oxygen atoms. So the electron picture for oxygen atom is on 4 sides 4 electrons you keep, on one side 2 electrons, and of course on the other side 2 electrons. So 2 pairs of electrons and of course 2 unpaired electrons. Similarly, in another oxygen atom also 1, 2, 3, 4. 1 here, 1 here. So this electron and this electron pair together, and this electron pair together. Therefore, we get 2 pairs of electrons. 2 pairs of electrons are formed, and of course these 2 pairs are shared in between both the oxygen atoms. So this is pair of electrons. This is pair of electrons. So this pair of electron, it belongs to only one oxygen atom. Therefore, these are unshared pairs of electrons. Unshared pairs of electrons are known as lone pairs, and these are referred as shared pairs. So these are shared pairs. Shared pairs are referred as bond pairs. Shared pairs are referred as bond pairs. So oxygen has 2 bond pairs. 2 electrons are shared. Since oxygen has 2 shared pair of electrons, oxygen is said to have double bond, O double dash O. Or otherwise, you can represent in this way also. 1 electron pair, 2 electron pair. This is oxygen atom, this is oxygen atom. So this is unshared pair of electron, this is unshared pair of electron. Similarly, for this oxygen atom also, this is unshared pair of electron and this is unshared pair of electron. So oxygen has double bond. Oxygen has a double bond. What is meant by double bond? If two pairs of electrons are shared, it is called a double bond. Now let us see nitrogen molecule, N2 molecule. N2 molecule. Nitrogen atomic number 7 with the configuration 2, 3, 2, 5, 2, 5. Outermost shell has 5 electrons, and of course it needs 3 more electrons to complete its octet. So the configuration can be written in NLX method also, 1s2, 2s2, 2p3. So electron picture for this is 2 electrons here, and of course this is 3 orbitals in p subshell. Each orbital gets 1 electron. Each orbital gets 1 electron. So what is the rule behind it? Each orbital gaining 1 electron. All these 3 orbitals are degenerate orbitals. Degenerate orbitals, pairing of degenerate orbitals takes place only when all the degenerate orbitals are filled with a single electron first. Therefore, this rule is known as Hund's rule. Hund's rule of maximum multiplicity. So nitrogen with one nitrogen atom, 4 unpaired 4 electrons, and of course valence shell has 5 electrons, so here you keep 1 more electron. Therefore this is unshared pair of electron or lone pair. So another nitrogen atom, 1, 2, 3, 4, and of course this is lone pair. So this is the 3 electrons pair up with each other. This electron and this electron pair up with each other. This and this pair up with each other, and of course this and this pair up with each other. Therefore we get nitrogen 1, 2, 3. 3 pairs of electrons are shared. 3 pairs of electrons are shared. So since 3 pairs of electrons are shared, it is referred as triple bond. Triple bond represented by N triple dash N in this manner. So or otherwise you can draw like this also. Nitrogen. So these are shared pairs of electrons, and this is unshared pair of electrons. Shared pair of electrons means they belong to both the nitrogen atoms. So nitrogen has a triple bond. Now let us see the bonds formed by carbon. Bond formed by carbon. Carbon with atomic number 6 and configuration is 1s2, 2s2, 2p2. So electron picture for this is lone pair of electrons, and of course since only 2 electrons are there as per Hund's rule, so 2 orbitals are filled with electrons. This is known as ground state. Ground state means before taking energy. But what happens, carbon takes energy and one of the electrons jumps into empty orbital. So this is 1s2, 2s1, 2px1, 2py1, 2pz1. So this is 1 electron here, and of course this is 3 electrons in 3 empty orbitals. So what is this? This is excited state. Excited state means after taking energy. Excited state means after taking energy. As it has 4 unpaired electrons, it can form, as carbon has 4 unpaired electrons in excited state. It can form 4 covalent bonds. So how these 4 covalent bonds formed with hydrogens? See, this is carbon 1, 2, 3, 4, and 4 hydrogen atoms. 1 here hydrogen, 1 here hydrogen, 1 here hydrogen, 1 here hydrogen. So this molecule can be represented as CH, 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 CH. So what is this molecule? Methane. What is this molecule? Methane molecule. So methane molecule has 4 single covalent bonds. So the number of covalent bonds an atom can form is known as a covalency. Covalency. So covalency means number of covalent bonds formed by an atom.
As carbon can form 4 covalent bonds in methane, its covalency is 4.
For nitrogen, covalency is 3. For oxygen, covalency is 2. For hydrogen, covalency is 1. Unique nature of carbon. Unique nature of carbon. Carbon has unique nature because of the following. That is, number 1, catenation. Number 2, formation of multiple bonds. Number 3, isomerism. So carbon has unique nature because of catenation, formation of it is able to form the multiple bonds with carbon atoms and other atoms, and isomerism. Now let us discuss these one after the other in detail. Number 1, catenation. Catenation is the property in which with valency 4, carbon combines with other carbon atoms to form long chains, branched chains, ring structures, and of course this property is known as a catenation. So catenation, carbon with valency 4 can form bonds with other carbon atoms to form long chains, branched chains, ring structures. This phenomenon is known as catenation. Now long chains. This is a long chain. Of course the valencies, the bonds are connected with hydrogen and other atoms. This is long chain. Branched chains. See, this is a long chain. In the middle of the long chain, one or more branches may be present. So this is branched structures. And ring structures. Ring structures means the two ends of the long chain are connected with each other. Therefore we get ring structures. This is if you keep double bonds here, alternate double bonds, this is benzene. If double bonds are not there, this is cyclohexane. So this is cyclohexane. And if you write like this is cyclobutane. So with valency 4, carbon can form bonds with other carbon atoms to form long chains, branched chains, ring structures, and this phenomenon is known as catenation. Because of the catenation, carbon can form a large number of compounds. Now let us discuss the formation of multiple bonds. Carbon with valency 4 can have the ability to form multiple bonds with other carbon atoms and atoms of other elements like oxygen, nitrogen, etc. So here, if all CC bonds are single bonds, they are called alkanes. If a double bond is present in between any two carbon atoms, these compounds are called alkenes. So alkanes are saturated hydrocarbons and alkenes are unsaturated hydrocarbons. And of course this particular substance is ethylene. And if if a triple bond is present in between any two carbon atoms, those compounds are referred as alkynes. Alkynes are also unsaturated hydrocarbons. Right, and this particular substance is acetylene. Carbon not only can form multiple bonds with other carbon atoms, but it can form multiple bonds with atoms of other elements also. For example, C double bond O. Carbon can form double bond with one oxygen atom, and of course these are free bonds. This group is known as carbonyl group. Carbonyl group. Carbonyl functional group. If carbon forms triple bond with N, carbon can form triple bond with N, and this is nitrile. Nitrile or cyanide. Cyanide. Nitrile or cyanide. So because of the ability to form multiple bonds with other carbon atoms and atoms of other elements like oxygen, nitrogen, sulfur, etc., carbon can form a large number of compounds. Now let us see isomerism. Isomerism. So, isomerism is the phenomenon in which same molecular formula can have two or more different substances due to the different arrangement of atoms, and of course it is known as isomerism. Let us take one example for this isomerism. Formula C4H10. This is the common name of the substance is butane. So here let us see different arrangements. All four carbon atoms in single straight line, therefore this is CH3, CH2, 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 CH3. So this is N-butane. N-butane. N-butane means normal butane. It is referred as normal butane because all the carbon atoms are present in single straight chain. And if CH3, CH, CH3, one carbon atom is made as a chain. This is a branched structure. So this substance is known as isobutane. Isobutane. Isobutane are 2-methyl. This is IUPAC name. 2-methyl propane. 2-methyl propane. So this is isomerism. Now let us take one more example. C5 H10, H12. This is pentane. Pentane. So the first structure is keep all the carbon atoms in a single straight chain. CH3, CH2, 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 CH3. This is N-pentane. N-pentane. N refers normal. Normal substance means all the carbon atoms are present in single straight chain. Now remove one carbon atom and keep it as one side chain. So this is CH3, CH2, CH, CH3, and of course here CH3. This is isopentane. 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 Isopentane are 2-methyl butane, IUPAC name. Now the another substance is keep 3 carbon atoms in a straight chain, and of course here one CH3 as a substitute chain or side chain, and one more side chain, that is CH3. So this is also pentane, and this is referred as neopentane. Neopentane or 2,2-dimethyl propane. Now, so the unique nature of a carbon is due to the 3 properties. One is catenation, ability to form double bonds, and isomerism. Because of all these characteristics, the carbon can form much more number of compounds when the carbon alone carbon with a few other elements can form substances which are greater than the compounds formed by all the elements put together. That's why we have to study the compounds of carbon as a separate chapter, that is chemistry of carbon compounds, or it is also referred as organic chemistry. Organic chemistry.
Let us do some multiple choice questions. The number of covalent bonds in nitrogen molecule is A1, B2, C3, D4. The correct option is C. The correct option is C. Nitrogen molecule has a triple bond. Now the second one is the covalency of oxygen. Covalency means it is the number of bonds can form. The oxygen has a double bond, therefore the covalency is 2, that is answer B. Next question is, which of the following is an example of a single bond? Hydrogen, oxygen, nitrogen and methane. In methane, single bonds are there, but four single covalent bonds. Hydrogen has a single covalent bond, oxygen has double bond, nitrogen has a triple bond. Therefore, the correct option is A. Covalency of carbon is 1, 2, C3, D4. Carbon can form 4 single covalent bonds, therefore the covalency is 4. Covalency means number of covalent bonds formed by the atom is covalency. So carbon has covalency 4, that is option D. Which of the following is a saturated hydrocarbon? C2H4, C2H6, C2H2, C3H4. Saturated hydrocarbon has the formula CnH2n plus 2. So which formula fits in that? Just you check. This is C2H6 ethane. So saturated hydrocarbon is ethane, option B. The number of isomers of pentane. Pentane can form, options given here, 1, 2, 3, 4. So number of isomers formed by pentane are C, that is 3 isomers. So option C. The property of carbon to form long chains, branched chains, ring structures is known as A. Catenation, B. Isomerism, C. Hybridization, D. None of this. The property of a carbon can form long chains, branched chains, ring structures is catenation. So option A. Which of the following formula can form ring structures? Ring structures means formula for ring structures is CnH2n. So which has CH4, C2H6, C3H8. All these are saturated hydrocarbons. Whereas C4H8 is unsaturated hydrocarbon. So it represents alkene as well as ring structure. Here the question is ring structure. Therefore option D is the correct answer. Also answer this. Write all the possible isomers of C6H14 hexane. Write all the possible isomers of C6H4 hexane, and of course have a practice.